Hello, welcome to Microsoft Build 2017. I'm Hannah Krager. I'm a software development engineer here at Microsoft in Developer Experience. I'm going to talk today about the bot-to-human handoff, what it is, why you might want to implement it in your own bot, and how some people are already using this. So I'm going to go ahead and start off with just reviewing what the bot framework looks like in action. On the left, you can see some users who are very happy to be using the bot framework. They can come to the bot through different channels, depending on what you want to implement. They can come from Skype, from Messenger, or from a custom direct line connection that we'll be using today called web chat. All of those channels come through what we call the connector, and that connector is how we're able to write code once for a bot and meet our users in whichever channel they exist in. Behind the scenes, your bot could be using any variety of cognitive services, machine learning models, querying databases, or doing web searches. None of that matters for the handoff. We're going to be concerned with another part of it. One thing that's important to note is that you can have multiple instances of your bot running. So if you have a very popular bot, you're going to need more than one server. So you're going to have to think about state and an external storage of state in order to manage your users effectively. So let's talk about the handoff. What are we talking about when we talk about handing off to a human? We have customers talking to the bot. We're going to have two types of users. One type is the customer. We have them talking to the bot, and we also have an agent or someone that we want them to be able to talk to. Maybe the agent is someone with a right answer to something, someone that can clarify a question, but we want them to be able to send messages to each other. So what we want to do is take this customer's conversation and point it at an agent. And then when we're done and the question has been answered or clarification has been given, then we want to pass control back to the bot. So we're going to talk about some real-world scenarios. And when I first started working with bots and the bot framework, there was some developers that I talked to who had worked for a company where they had an existing user base or customers, and they also had an existing agent pool or customer service representatives. And they were already communicating via different social media or chat interfaces. So they wanted to build a bot. They could automate some of the questions being answered and be able to meet their customers wherever they were, but they needed to still be able to escalate issues to a human. Or if the bot couldn't handle every situation or there were edge cases, be able to pass off to a person who had the right authority. So that is the first scenario we're going to talk about. Once we worked on that, we realized quickly agents need to know whether they need to pick up a conversation. So being able to monitor a conversation in real time and then take over and answer questions is really an efficient way to do it. And then the last one that we're not really going to get into today, but wanted to let you know we acknowledge it and we're working on figuring out the best way to solve it, is what we call a supervised handoff. And that is where you have a bot, but you're not quite ready to trust your brand with the bot. You don't want to automate every response without a human assuring that it's not going to be something that damages your business or makes you look bad. So what would happen is a customer would ask a question, and if it were a question that we don't want the bot speaking on our behalf quite yet, that question would be sent to an agent. The agent could see the possible answers the bot wanted to give and then decide which one to send back. So let's go ahead and get started talking about the handoff and connecting agents and customers. So in the bot framework, everyone is a user. For our case, we need to differentiate between two different types of users, customers and agents. And fundamentally, how the bot framework works is that a user, whether they're a customer or an agent, sends a message to the bot runs whatever logic you have behind the scenes and sends some message back. This is what the bot framework is optimized for. So when we talk about the handoff, we are taking advantage of some things the bot framework gives us, but we do take advantage and work around the default. Okay, So the first thing we're going to need to do is decide which user is which type of user. So we need to start with agent recognition because agents will have control in this situation. They will have more input over how the bot behaves and over what the customer sees. So in the code, we just have a function that takes in information about the user and returns a Boolean value. True or false, are you an agent? You can do this in many different ways. You can use your username and a channel. Palindromed is my go-to username, so that's there. You can also do something more complex with auth tokens and passing those back and forth via a direct line back channel, so it never shows up in the bot. It is handled behind the scenes as it would be in a website. We took a very simple approach with this sample, and it is just a username that begins with agent. So we'll go back to our bot, and so we have these users, and they are all talking to the bot the way that it was built to function, but we want to change that. And there are multiple ways to approach this problem. We decided to do it in the Node SDK implemented through middleware. The first piece of middleware we added is a router. This is where there will be enough information about the message to tell where it needs to be sent to. The next piece is metadata. Here's where we store information about the user, about what we know of the conversation in order to tell the router where to send a message. Included in this data, we have what we call a conversation, and that can have things like the customer address, an agent address if they've been connected to an agent, a transcript of how things have been going, that's every text sent between the bot and the customer, and then state. And so we have 4 different types of state, and that is really how the behavior of this handoff is driven. So the first state we're going to talk about is bot. And so just taking a look at this code, you can see that we have a conversation state. It is bot, and we are calling something called next. What's important to know about this, whether you end up using C# or something else to build your bot, is that this is what allows the bot code to execute. Calling next moves you from middleware to whatever logic you have behind the scenes. So a customer comes in, they hit the router checks to see what state they're in, sees that they're in the state of bot, and they pass the message along to the bot. The bot can query, can do whatever logic, however complex or simple, and then send a message back to the router. We check again, we're still in the state of bot. The message is sent back to the customer. So this is the normal function of the bot. It's also the default in this sample. We want the user to come in, or the customer, to come in and be able to interact with your bot and take advantage of whatever you have in there. So if we start here, then you might be wondering how we change state, because we start in one and we need to change to another. This can be done through a variety of ways. You could have bot logic that does sentiment analysis on incoming text. Is your customer getting frustrated? Are they asking that one question that you know your bot cannot answer? Did they ask for help? You could bake in logic to your bot to recognize someone's request to talk to a person. Connect to an agent. Can I get a person on the line? I need help. Anything like that, it's up to you to do it that way. Another common answer that developers have found is creating a custom user interface for the agent, and that can include buttons that, when clicked, can take over a conversation or change state in some way. In this sample, we have a command middleware, so it looks for specific text inputs and changes state based on what was asked for. So the second state, this is when a customer has asked for help. They will be put into a state of waiting. So in this case, the bot has reached a dead end. So we want to stop execution of that code, and we want to find a person for them to talk to. So you can see that we have something called session send. And whenever you see that, that means that the bot is interacting with the customer or the user who started that interaction. So it is a direct response to an input, much the way the default functionality of the bot works. And we're returning. We're not calling next. The bot is at a dead end, so we're stopping until we can get a person involved. Stepping through that, we have a customer who says help. And in our commands middleware, this is the term that the middleware looks for in order to stop execution of the bot and look for an agent. So we have typed in help, commands recognized it, went to the conversation data, changed the state, so now the behavior is to send a message and back and do nothing else. And this will be the cycle until we have an agent connect with them. So in the agent state, you'll see something else that has changed. We're still not calling next. The bot is out of the picture for this, and whatever language you're implementing in, that is a key. When an agent takes over, logic behind the scenes needs to stop executing. Otherwise, your customer could be seeing bot responses, quite possibly the I don't know response, in addition to the agent message, which is not ideal. So the customer has come into this routing, and we see that they're in the state of agent, and that we have something called conversation.agent, and that is an address. And if you remember back to the connector on the first slide, that is how we are able to talk in any channel. It gives us a baseline of how to address a message. So we can say, instead of going back to the customer or going to the bot, we address it to another person, in this case, this particular agent, who can be in any channel. And then we just return. We pass the customer message to the agent, and then we wait, because we don't want the bot to execute. We only want to send messages between the two users. So in order to get to the state of agent in our example, an agent would type waiting, and this goes into the conversational metadata, looks for anyone who is in the state of waiting and has been waiting the longest. So it is a queuing system in this example. So we update their state, so now a customer comes in, and like we saw before, they'll hit the commands middleware and then come to see where they should go, and our data says, we have an agent address, we're in the state of agent, let's send the message over there. And that's what happens. And so an agent, likewise, can go through the commands, go to the router, and this is where we look up, are they in a conversation? Is this particular agent talking to someone? In this case, they are, so we have that address and are able to send that message back to the customer. So the next state is the different scenario. This is where we want to be able to see how a user's interaction with a bot is going. Is the bot answering questions successfully? Is it struggling? Is my customer frustrated? So what we will do here is actually a combination of what we've done before. Through the bot, we are sending a message. We are passing that text like we did when we were in the agent state. We're addressing it to the agent. We are also calling next. So the agent will say watch and then a username. We're just calling them customer right now. The commands middleware recognizes this, changes the state of the conversation that that customer is in. And then as a customer comes, they will hit the commands middleware as usual, be routed. We'll see in the data that they're in the state of watch, that we do have an agent address, and then a message will be sent, passed along to the bot for execution, as well as sent to the agent. All right, so now we're gonna go see what this looks like in action. All right, so let's go ahead and get started. So we have an agent over here, and we're using web chat with just a small login screen. This is also open source on GitHub, as the rest of the code is. So we'll go ahead and just type a hello message. And you'll see that we are given a list of options. It is recognized that we are an agent and we have some things that we can possibly do. And then over here, we'll have a user. We'll call him Bill. We'll have him say hello. So he's connected to the bot. One of the things that we can do as an agent in the sample is see who is connected to our bot and what state they're in. So we can see that Bill is here and he is talking to the bot. So we can decide we want to watch Bill. This is the second scenario we talked about where you can see how a conversation is going. He might want to tell us about himself. We have a dialogue that'll ask his name, and you can see that in real time, we are getting those same messages sent to the agent as we are in Bill's conversation. One thing to note, and this is part of the fact that we're working around the default behavior of the bot framework, is that every message going to the agent looks like it's coming from the bot. And there, right now, is no way to say that it's coming from someone else because we're using the connector and addressing through the bot framework. All right, so Bill looks like he's getting along fine, so we can disconnect. And then you can see if he answers this question, everything continues. We do not get any more messages. So if we have another user that comes in, we can check to see that he did in fact show up. And maybe he just wants help right off the bat. So he is going to be put in the state of waiting. And you can see that he doesn't advance to the bot. Everything is, we log the message, you can see it show up in the chat window, and the same message is being sent back to him, that we're waiting for an agent to connect. And if we take a look at everyone's state, we can see that Ryan is waiting to talk to an agent. So we can say, waiting. And you can see that we were connected to Ryan, and it replays his conversation, so we have some context for what his issue may be. So we can say, hey, and you can see it come up in his screen. Again, we're not talking to the bot at all. This is a message that is hitting the middleware and being rerouted to this customer's conversation. You can see that it comes the other way as well. And still everything that's incoming is addressed as if it's from the bot. Again, that's just the functionality of the bot framework. So let's go ahead and disconnect from Ryan. And you can see that if we say something, now instead of being passed, we're seeing our options again. And Ryan is seeing the bot behavior again. We have successfully disconnected. All right, and last one. We'll go ahead and log Matt in. We can take a look, and now we have 3 users talking to the bot. Let's ask Matt about himself. And let's see what Matt is up to. And if we take a look at state now, you can see that Matt is being monitored by an agent, which is us. So we can answer these questions. You can see that things are being passed to us as well. Maybe Matt hates Node. And now the bot is confused. And since we're already connected to them, we don't have to wait for Matt to get extremely frustrated. And here, since we're already connected, we don't need to find an agent. We can just type the word connect, and we're connected to Matt. We can tell him that he doesn't have to write Node. You can write C# too. And then he can send a message back. And then we're done. We can disconnect. And Matt is now connected to the bot again. All right, so that is what I have for you for the handoff to human using the bot framework. We have a few links for you here. The sample code that you saw in the demo is all available on GitHub, as is web chat, the user interface that you saw us use to get there. If you go ahead and take a look at that, there are also many samples online. We have some documentation for you to look at. And good luck implementing your own handoff. Thanks.